Okay, today in 6.3, proving that a quadrilateral is a parallelogram. So over on the left side of that squiggly red line are the theorems that we learned yesterday. Theorems 6.1, 6.2, and 6.3. What we're doing today is we're looking at the converses of each one of those theorems, okay? So, for example, theorem 6.1 says opposite sides of a parallelogram are congruent. Theorem 6.5 right next to that says if opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so in theorem 6.1, you're given that the opposite sides of a parallelogram are congruent. In theorem 6.5, it says if the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So 6.1 and 6.5 go together, as do 6.2 and 6.6. So theorem 6.2 says opposite angles of a parallelogram are congruent. And then theorem 6.6 says if opposite angles of a quadrilateral are congruent, then that quadrilateral is a parallelogram. And 6.3 says the diagonals of a parallelogram bisect each other, whereas theorem 6.7 says if the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. Okay, so we learned the main theorems 6.1, 2, and 3 yesterday, and now we're learning the, did I label those wrong? Now we're learning like the flip sides of those, the converses. So I'm looking to see what I'm missing for. Oh, theorem 6.4 was the one with all the 3 parallel lines. Okay, just wanted to make sure I did not number them incorrectly. Okay, so again, we've got our pairs. Okay, one is the theorem, the other is the converse. Okay, so for quick check 1, it says find the values for A and C for which PQRS must be a parallelogram. Well, in order for this PQRS to be a parallelogram, opposite angles have to be congruent. Okay, so that would be this angle and this angle. They have to be congruent. Okay, so we'll talk about that in a second. And also, opposite sides have to be congruent. Well, that part is easy. Opposite sides, 3C minus 3 is equal to C plus 1. So this just says find the values for A and C. Now we can also then find the lengths of the sides. So we'll subtract a C over here, and then from the 3C on the left to get 2C, and then we'll add 3 on both sides to get 2C equals 4. So C is equal to 2. That means that each side is 3 units long. Each one of those shorter sides. Okay? And remember that we have, if we don't have opposite angles, we did have the angles that were next to each other. Okay? So angles that are next to each other are supplementary, consecutive. Okay? So these two angles here are consecutive. They are not opposite. But remember, if opposite angles are congruent, that means that consecutive angles are supplementary. So A plus 40 plus A equal 180 degrees because A plus 40 and A are consecutive angles. So 2A equals 140 and A is equal to 70. So if A is equal to 70, right here, 70, then the supplement to that, 70 plus 40, is 110, because 110 plus 70 equal 180. So remember, opposite angles are congruent, consecutive angles are supplementary. Don't let that trip you up in a problem like this. Okay. And then our quick check 2, and we will be done. Okay. So here we're given this set of information and we're asked, is that enough to prove that PQRS is a parallelogram? Well, remember, if a quadrilateral is a parallelogram, opposite sides have to be parallel, and here they are right here, okay? And opposite sides have to be congruent. So here's that and that for PQ is congruent to SR, okay? So opposite sides, and it goes to follow that if PQ and SR are the same length, then PS and QR would also have to be the same length, okay? So yes, that is enough to say that PQRS is a parallelogram. Now we're going over to the other shape, and we're asked if that is enough information to tell us that DEFG is a parallelogram. Well, here we're dealing with diagonals. And remember, diagonals bisect each other. So if that be the case, DF cuts EG in half. Well, if EG is cut in half, they would either both have one tick mark or they would have two tick marks, okay? So in this particular instance, DF does not cut EG in half because GH and EH are not the same length. So that is not a parallelogram because the diagonals do not bisect each other. Okay, so that's it for that simple lesson. Okay, get to work.